Hello National 5 and welcome to Homologous Series Lesson 10. Okay, so as usual we've got a wee starter. I want you to name this alcohol here. Okay, then question 2, I want you to name the functional group found in all alcohols. Then question 3, why does hexane 2-ol have a higher boiling point than butane 1-ol? Okay, question 4, are alcohols soluble in water? Simple yes or no. Question 5, we've got an alkene, we add water to it and we get two products. I want you to draw those two products. Then once you've done it, if you want to name the products, even better. Then once you've done it, I want you to name this type of reaction found in question 5. So when we add water to something, what do we call that? Okay, so pause the video, do the questions, and then I'm going to go through them just now. So question 1, name this alcohol. Now, we've got a branch, we've got a functional group. Remember, OH. Okay, so we start from the side closest to the functional group, so that's this side. So that's carbon 1, 2, 3, 4 and 5. We circle the branch, just like that, and then we start naming it. Okay, so our longest chain is 5, so that is pent. Now it's an alcohol, so it's going to be pentan, and because the functional group is on carbon 1, we call that pentan 1-ol. Okay, so that's the longest chain done, dusted. Now, we've also got a branch. Yeah, you'll notice on that branch we have one carbon. Okay, so we call that methyl. And what carbon is that methyl branch on? It's on carbon 3, so we call that 3-methyl pentan -1-ol. Yeah, simple. Name the functional groups found in alcohols. You should know that. It is the hydroxyl group. Okay, and if you want to, it didn't say draw it, it just said name it, but that's how you draw it. Question 3, why does hexane 2-ol have a higher boiling point than butane 1-ol? Well, if we look down here, here's the answer. Okay, so hexane 2-ol has more carbon atoms. Yeah, hex is 6, bute's 4, so it has more carbon atoms. What does that mean? It means there's more van der Waals forces. Okay, so if we've got more van der Waals, it makes it harder to break. So if it's harder to break, there's more energy that's required, therefore you have a higher boiling point. Okay, just try and squeeze that in there. Higher boiling point. Okay, you need to mention that. You need to mention it's got more carbon atoms. You need to mention, therefore, it's got more van der Waals. And you need to talk about how it's harder to break, so more energy is required. You need to say all those points in order to get the marks. So, question 4, are alcohols soluble in water? You should know that. Very simple. Yes. Simple, yeah. Now, alcohols are soluble in water. Alkanes, alkenes, cycloalkanes, they aren't, so we call them insoluble. Okay, so make sure you know that. Question 5, we add this over. Now remember, grab another pen, the water splits down here, and we have a H, and we have the OH. Okay, now that H will add to that one, and the OH can add to that carbon. Okay, so what we're going to get is we've still got 3 carbons, 1, 2, 3. Remember the carbon-to-carbon double bond breaks? Just put the H's in exactly the way they were. Yeah, nothing changes, just the same. And we have the H going to that carbon, and the OH going to that carbon. Okay, now also the H could also add to that carbon. Okay, and the OH could then add to that carbon, so we get a different alcohol altogether. So again, we've still got 3 carbons. Yeah, draw the H's just as they were. Yeah, nothing changes. And then we have the OH on the middle wrong pen. We have the H on that carbon, and then we have the OH on the middle carbon. Okay, so if you wanted to name them, that would have been propan 1-ol, and that would have been propan 2-ol. So these two here are isomers. Yeah, remember isomers, same molecular formula, different structural formulae. Okay. Right, and this one here, name this type of reaction found in question 5. You could have said addition or hydration. Okay, addition because we're adding, hydration because it's water. Okay, so you could have said addition or hydration. Right, perfect. Right, so what we're going to do, we're going to look at carboxylic acids. Now these are my favourite homologous series, you guys will love them. Okay, so we're going to make a wee note. All carboxylic acids contain the carboxyl functional group. Okay, so alcohols contained the hydroxyl functional group, carboxylic acids contain the carboxyl. Okay, and you need to know that, and you need to make sure you don't confuse them. Okay, because it's easy done. Yeah, we can easily confuse them. So I'm going to draw it for you. So we've got a C, we've got a double bond O going to an OH. Okay? So very important we know how to draw it. Now, a shorthand way of writing that is COOH. Yeah? C, double bond to the O, single bond to the OH. COOH. Okay? You need to be able to recognise that. C, double bond O, OH. Yeah, that's a carboxyl functional group. Now, I'm going to give you the simplest one, which is this. Okay, we'll make a wee note just here. All carboxylic acids end in oic. Okay, and you'll see what I mean when we get into that. So the very first one, we've got one carbon. Again, this goes back to the very first lesson we ever did. You need to know your prefixes. So we've got one carbon, so our prefix for that is meth. Yeah? And because it's a carboxylic acid, in fact, really I should have wrote anoic. Okay, so it'd be meth and oic. Okay, so this molecule here is called methanoic acid. Yeah, the next one would have two carbons. Okay, just fill in the H's, make sure there's 4 bonds coming out of each carbon, and notice the shape that I'm drawing this the carboxyl group. It's going off in an angle. The OH goes off top right and the OH bottom right. Okay, so this has got 2 carbons, so the prefix for 2 is eth, and then it ends in anoic. Okay, so this becomes ethanoic acid. Yeah, so simple. Now the next one is 3 carbons. Okay. What's the prefix for 3? Prop. So this becomes propanoic acid. And that's it. Yeah, it goes methanoic acid, ethanoic acid, propanoic acid. If we were to take it further, butanoic, pentanoic, hexanoic, heptanoic, octanoic, it goes on, okay? It's the exact same. I actually think that carboxylic acids are a lot easier to name than alcohols, because it's so much simpler. Now, what I'm going to do for each one, I'm going to do the shorthand. Okay, so again, we've got a C. We've got the functional group COOH. Now, what else do we have? We've got a H, so that becomes HCOOH. Yeah? Ethanoic acid. If we break this down, like we do them all, we put a wee dashed line in between the two carbons. So the first one we see is CH3, and then we've got COOH. Simple. Yeah? The next one, if we break it down just like that, we've got CH3, CH2, COOH. And that's it. Yeah, that is it. So, that's how we name carboxylic acids. Yeah. Right, now I'm going to just give you a wee subheading. We're going to call that branches. So let's go for this here. Okay, now what's very important about this? Yeah, carbon on the carboxyl is always, helps if I can spell, is always carbon 1. Okay, so what I mean by that is the functional group here, the carbon that's a part of the carboxyl group, is always carbon 1. Okay, doesn't matter where it is, it's always carbon 1. So if that's carbon 1, okay, that becomes carbon 2, that becomes carbon 3, and that there is our branch. Okay, and that's it. Yeah, now our longest chain is 3, so that becomes propanoic acid, yeah, because it's 3 carbons, and this here, the branch, has 1 carbon, okay, so it's a methyl group, so, and it's on carbon number 2, so this becomes 2-methyl propanoic acid. Yeah, and that's it. It is so simple. Okay, I'm going to do another one. So we've got 5 carbons in a row. Okay. And then there is our carboxyl group. Right, so let's name it. So what becomes carbon 1? Now we'll look for the functional group. The carbon that's a part of that functional group is carbon 1. So that's carbon 1, 2, 3, 4, 5, 4, 5. So it doesn't matter where we go. So we just go straight across, 4, 5, and we circle our branch. Okay. Now we name the longest chain. So the longest chain's 5. So what's the prefix for 5? Pent. Okay, and it's a carboxylic acid, so it ends in anoic. So this becomes pentanoic acid. Yeah? And then this branch here has 2 carbons. So if you can remember, if it's got 2 carbons in the branch, it becomes ethyl. And it's on carbon number 3, so this molecule here is 3-ethyl pentanoic acid. And you know what? That's it. Yeah, that is it. Doesn't get any harder than that, to be honest. Right. Our next subheading is going to be called uses. Okay, so we found out last lesson on alcohols that alcohols have 3 uses. Food and drink, can be used as a fuel, and it can be used as a solvent as well. Okay, now carboxylic acids have 2 main uses. Okay, so these 2 main uses are food and cleaning. Okay, this one here for food, I'm going to focus on one in particular, is ethanoic acid. Okay, so that is 2 carbons with the carboxyl functional group. Okay, and what ethanoic acid is, not a lot of people know this. Ethanoic acid is actually just vinegar. Okay, so the vinegar you put on your fish and chips, that's ethanoic acid. Okay, and that comes up in the exam all the time. Okay, all the time that comes up. Yeah. Right. So that's all you really need to know for that. You don't need to know in detail about the cleaning. We'll touch on that when we come back. But all you need to know is that the 2 main uses, food and cleaning, and in particular, ethanoic acid is used for vinegar. Okay? Used for vinegar. Right. We're going to do some questions now, because I feel like that's a good place to stop, and we'll carry on carboxylic acids on Thursday. Okay, so I want you to do some questions to try. Okay, so very first one, I want you to try and do this without looking back in your notes. Okay, so name the functional group found in carboxylic acids. Okay, and just as an extra question, I want you to draw the functional group as well. Okay, question 2. I want you to draw, there's going to be a few here, I want you to draw butanoic acid, and I want you to draw 2-methyl heptanoic acid. Okay? Right, question 3A, I want you to name, okay, we'll do 2 again. So I want you to name this. Okay, name that. I want you to name this one. This one I'm going to do a wee bit different. See how you get on with this one. And let's go for this one. I'm going to change that. Make that a branch. Okay, I want you to name that one. And then question 4. What is ethanoic acid used for? Okay, so guys, I want you to try these questions. I'm going to go through them just now so you can self-mark them. Okay, so answer those questions, pause the video, answer the questions, and then when you're finished, I want you to unpause it. So, very first one, name the functional group found in carboxylic acids. That is our carboxyl group. Okay, and if we wanted to draw that, that'd be a C, double bond O, OH. Yeah, you could also have drawn the shortened structural formula, however, we tend to always draw that one. Okay, draw butanoic acid, so but means 4 carbons, so 1, 2, 3, 4. Draw in your carboxyl group, and then there's no branches, so very simply just fill in your H's. Make sure each carbon only has 4 bonds. Yeah, this carbon here has got 1, 2, 3, 4. Remember, the double bond counts as 2. Okay, methyl heptanoic acid, hept means 7, so 1, 2, 3, 4, 5, 6, 7. Draw in your functional group, and then draw in your branches. Okay, now if we've drawn 7 carbons, that's carbon 1, 2, 3, 4, 5, 6, 7. Okay, we want a branch on carbon 2, so on carbon 2, and it's a methyl branch, so it's only 1 carbon, and it's like that. Yeah, and then once you've done that, make sure all your H's are in, like so. Just like that. Boom, there you go. Yeah, 2-methyl heptanoic acid. Right, this one here, name. So remember, the carboxyl group, the carbon that's a part of that is always carbon 1. So this has got 3 carbons, no branches. This is propanoic acid. Yeah, prop because it's 3 carbons, anoic because it's a carboxylic acid. This one here, yeah, we've never seen this before, but all we've done is just, instead of drawing the carboxyl group here, we've drawn it on the left side. Okay, so this becomes carbon 1 this time. Yeah, and we've got a branch. So be careful. Yeah, now remember the C has to be bonded to the O. Yeah, we can't draw it like that. That is bad news. Okay, so our longest chain's 4, so that is butanoic acid, and we've got a branch on carbon 3. Just this one here has 1 carbon, so we call that methyl, and because it's on branch 3, that is 3-methyl butanoic acid. Okay, this one here, again, starting the carbon that's a part of the carboxyl group, so that's 1, 2, 3. This time we've got 2 branches. Now this is a more difficult one. Our longest chain's 3, so it's propanoic acid. Yeah. Now we've got 1 carbon here, and we've got 1 carbon here. So there are methyl groups, okay? But because we've got 2 of them, we call this dimethyl. Yeah, remember that? Okay, so dimethyl. And where are they? What carbon are they on? They're on 2. Okay, so we've got one carbon on 2. Where's the other one? It's also on 2. So for this one, we need to write 2, comma, 2 dash dimethyl propanoic acid. Yeah, a lot of people tend to write 2 dash methyl propanoic acid. They forget the second 2 and they forget the di. So be careful with that because that can crop up now and then. Okay, and then question 4, what is ethanoic acid used for? It is used for vinegar. Yeah, and that's it. Okay, so let me know how you've got on. You can send me a picture of your work. You don't have to upload it to assignments, just you can send it to my email, that's not an issue. And we'll carry on with properties of carboxylic acids on Thursday. Right, thank you.